So that is average radiation intensity. Average radiation intensity. Average radiation intensity. Okay, so what is the meaning of this one? Simply, in the previous case, the definition is simply power density means power per unit area, watt per meter square. But here, simply the radiation intensity means power per unit solid angle. Okay, I will tell you later why this extra definition we are having, because already we are having some definition for power density. Then why we are having some new definition intensity? Okay, I will tell you later. But for the time being, you just understand the definition. Okay, just try to know the average power. Okay, the average power radiated per unit solid angle, per unit solid angle, average power radiated per unit solid angle is called as radiation intensity. Okay, radiation intensity. Okay, so why we are having some different definition here, some different definition, please. And again, please do not worry about this average, sir. Average means always RMS value. Okay, you worry about the remaining things. Okay, power radiated per unit solid angle, power radiated per unit solid angle. Now, I will ask you simple question. Say, for example, I am having isotropic radiator. I am having isotropic radiator. Okay, I have 10 watt power. Then what is the solid angle of, what is the radiation, average radiation intensity of isotropic radiator? Anybody? As per this definition, what is the definition is telling? Intensity is equal to what, sir? Power.
Average power divided by.
Okay, average power. Average means please remove the term average. Average means always RMS value. Okay, power divided by solid angle. Power divided by solid angle. The two what? Total power divided by solid angle. Then what is the total power here? 10 watt. What is the solid angle of isotropic radiator, sir? 4 pi. Okay, so 4 pi. So that is the intensity, average radiation intensity of isotropic radiator. Now what I am going to do, this isotropic radiator will radiate energy in all direction. That's why I am putting 4 pi. Okay, that's why I am putting 4 pi. Now I am going to give you another situation, some practical antenna. Okay, some practical antenna. Okay, again the solid angle, okay, of the practical antenna is something like this. Okay, if the solid angle, what is the angle, solid angle here? Anybody? How much solid angle is there? 4 pi up. Imagine in 3D, how much solid angle will be there? Half sphere, hemisphere I am taking. What is the solid angle of the hemisphere?
2 pi.
Yes, 2 pi. Now what will be the intensity? Intensity will be 10 watt divided by 2 pi. In which case the intensity is more, sir? Second or first? Intensity and the case sir adhigama irukku. First case or second case?
Second case, sir.
Second case intensity has to be high, because you are concentrating your power only in a particular direction, only towards right. In the first case you are concentrating your power in both right and left. Now only right side you are concentrating. Or in future there may come some antenna, it may concentrate power like this, only with some angle, some solid angle. It may be a pi or less than pi by 2 or something like that. Then also you will be see what is the total available power with you, for how much solid angle you are concentrating your power. Okay, the total power radiated per unit solid angle is called average radiation intensity. Okay, average radiation intensity. Okay, that means what? Okay, see what this unit is giving you, this parameter. See how effectively you are concentrating power in a particular direction, how effectively you are concentrating power in a particular direction. That's why we have this definition. Okay, this definition is with respect to direction. Okay, how much angle you are radiating. Okay, what is the coverage angle of your antenna? Okay, it's directly giving you the coverage angle of your area. Once if your coverage angle is less, Okay, definitely you can give more power to the consumers. Once if the coverage angle of the antenna is less, then it can give you the more power, because more intensity, you can give them more intensity. So what is the meaning of this one? Okay, so I've drawn a little bit wrong, because once if you concentrate your power, you will have some extra intensity like this. Okay, because it will go like this. Okay, because you are concentrating your power only in a particular direction. Now if somebody comes, if they concentrate their power in a lesser angle, then the intensity of power or value will increase in a particular direction. Okay, that's the idea of the average radiation intensity. Please note down the definition: power radiated per unit solid angle. For the time being, please forget about average. Average means you are using RMS value. Okay, once if you understand that, please remove the term, or otherwise that will be confusing to you. Okay, always if you use average term, that's why I remove the term here, total power per unit solid angle. Okay, so that's average radiation intensity. Okay, now we'll extend a little bit extra here. See, the notation of radiation intensity is U bar. The notation of radiation intensity is U bar because it is a vector quantity, because you should know in which direction you are radiating the power. Say I have clearly told you are radiating the power in right hand side. That means so that it should be a function of angle, in which direction you are radiating the power, in which direction. So always the radiation intensity is always function of angle, because you are dividing by solid angle. That means what, your radiation intensity is always a function of angle. Okay, this is always function of angle. Okay, you are concentrating power on some direction. Okay, per unit solid angle, how much you are concentrating, that is given by radiation intensity, but it is always function of what's our angle. It's always function of angle. Okay, this unit is always function of, because once if you observe here, definitely in the denominator you are putting something 4 pi or 2 pi like that. So that means what, this is always function of angle, always function of angle. Okay. Okay, so now that's why again it will have some directional properties. Okay, once if the angle comes, then definitely in which direction you are radiating. So it's a vector quantity. And then once if you have U bar is the average radiation intensity. Then if I calculate the average radiation intensity for isotropic radiator, ISO isotropic radiator, what is the average radiation intensity for isotropic radiator? So what is my total transmitted power? I took 10 watt there, but in general WT, total power transmitted in terms of watts. Okay, then simply that is 4 pi. Simply that is 4 pi. But see, in general, our formula is omega t is equal to integral P dot ds, But for isotropic, because isotropic, you are having regular sphere. Once if you have regular sphere, this power density, once if you have regular sphere, what you can replace this integral ds divided by 4 pi r square. Okay, because for isotropic, once if you have isotropic, that indicates the regular sphere. Okay, regular sphere, you know whenever you have regular structure, you can replace the integral with the help of simply multiplication, because what is the surface area of your imaginary circle? That is 4 pi r square. This is what is the power density on the surface area, and what is the surface area value. Once if you multiply these two, you will get what is the total power transmitted? What is the total power transmitted? WT. What is the total power transmitted by the system? So that means what? That for isotropic radiator, only for isotropic, but for other antennas, you cannot do this replacement. Okay, sorry, you cannot do this replacement. But for isotropic, you can do this replacement. So this is simply power density into 4 pi r square. Power density into 4 pi r square divided by 4 pi. So that means what? Isotropic is equal to 4 pi cancel r square PD. So simply for isotropic radiator, okay, for isotropic radiator, this is r square PD vector, or the notation is, you can use any other notation, PR also, that is also giving the power density. Okay, PR, or otherwise you can also use P average. Okay, everything is same. Okay, so this is another relationship, how the radiation intensity is related with the average power density average. This is true only for isotropic radiator. This is true only for isotropic radiator. Okay, for others you will have some different answers. Okay, once if you solve some of the problem, then you'll come to know, okay, what is the nature of U. Okay, but this is true only for isotropic. Okay, only for isotropic. Because for isotropic only you are having regular sphere shape. For other antennas, the shape is not regular. It is completely of irregular shape. Once if it is irregular, you cannot replace this integral with this multiplication. Okay, so this is true only for isotropic radiator. Next property is directive gain. Okay, gain of the antenna.